Today we're looking at Glencoe, Course 2 Math, Lesson 5-7. Let's not skip a chapter. Lesson 5-7 on subtracting expressions. Now, when we added expressions, we looked for ways that we can use our associative and our commutative properties to take our like terms, put them together. Okay? And when we are adding, we are combining those things. When we subtract, we're going to essentially do the same thing. Okay? So, if we start with 6x plus 3 that quantity minus 2x plus 2 we know that we can't use our properties if we have a subtraction sign. So what we're going to do instead, we're going to KCA. But we're not going to KCA a single term. We're going to KCA expressions. So we're going to keep all of the 6x plus 3. We're going to change the subtraction to addition. And we're going to take the opposite of this whole expression. So that means that we're going to take the additive inverse of 2x, which is negative 2x, and the additive inverse of 2, which is negative 2. Okay? It's kind of like we distributed a negative. Alright? Okay. Now, because we kept the first term, we changed the subtraction to addition, we took the additive inverse of my second term, which is an expression. I have 6x plus 3 plus negative 2x plus negative 2. I can use my commutative property to say that I have 6x plus negative 2x plus 3 plus negative 2. 6x plus negative 2x is 4x. 3 plus negative 2 is 1. So my solution ends up being 4x plus 1. What do you think?
I think it's correct.
You think it's correct? What do you think about what we did? Do you think we could do this?
No.
Yeah.
Why not?
Because it's hard.
Because it's hard. Okay? Something being hard doesn't mean that we can't do it. Something being hard means that we might need a little more practice. So, here's what I'm going to do. You create one. Alright, good sir. Can I, first of all, I need two numbers.
Oh.
Go ahead, give me the two numbers.
1 and 2.
Okay? So, and can you choose a variable for me?
Oh.
Go ahead.
Y.
Y, alright. 2y plus 1 minus, I need two more numbers.
Oh.
I got you.
Yes, sir.
1 and 2.
3x. I mean 3a.
No.
Plus 9.
You have to have the same variable.
No, you don't. No, you don't.
That's what I said.
We can add in another variable.
But it ain't gonna go nowhere.
It's a. You got to add them all together.
We can still simplify this.
What?
How many terms will my final answer have?
2.
1, 3.
3.
Wait, how do you get 3?
Because I have a y term, I have a constant or a number term, and I have an a term.
And
So
Y term.
I can combine my y's.
Yeah, that's why I said 2.
But then I'm left with 1, 2, 3 terms.
Oh, I thought you were talking about variable.
Okay. going to KCA or distribute my negative to my second expression. Okay? 2y plus 1 plus negative 3a plus negative 9y. What property says I can rearrange things to put my like terms next to each other? Yes, sir? The commutative property. 2y plus negative 9y plus 1 plus negative 3a. Now, I'm going to tell you a secret.
Yes.
Shh.
I can't.
It's okay because this secret you're allowed to share.
Why? Then why is it a secret?
Jack, just shush.
Because we don't know it yet. Shh. Remember, we're video day. Please don't use names. All right. Here's the secret. When we write expressions, for it to be considered grammatically correct, you write your variables terms in alphabetical order, then you put your numbers at the end. So, which term is going to go first in my solution? Yes.
A.
The A. So we have negative 3A
Plus
plus
2y.
Negative 2y.
It'll be
negative 2Y?
No, negative 9y.
No.
negative.
Can we combine the two? Hold on. Hold on. You're trying to work too fast.
Then it would be negative 7y.
Negative 7y. Because 2y plus negative 9y is
It's
negative
7y.
7y.
I'll go crap. Why did you stop?
Plus 7. I mean 1.
Plus 1.
Hey.
I stopped you guys because your brain was going too fast. It was going to crash and explode, but not get to where we needed to go.
I was getting it right.
You were on the right track.
But your brain wasn't either.
Ah, your brain was going too fast for the track. Okay? It wasn't going to be able to stop where it needed to. So, can we do this if we have expressions with multiple variables?
Yes.
Yeah.
Cold.
Can we do this if we had a... Hold on. Hold on. Could we do this if we had to distribute?
Yeah. No.
Yeah.
Yeah.
Yes.
Let's look at one where we do that.
Yo, why'd you say that?
Okay. That problem that I'm looking at is here. Okay.
We don't example.
You said example 6?
What page is this?
398.
No, we're not doing example 6. Where's the one I was looking for? Hold on.
Example 5.
No.
Example 4.
I don't see the notes.
Guys, hold on just a second.
2.
Hold on just a second. I can't find the one that I was looking for. Okay.
Oh, it's example 1.
Hold on. Let's say that I have okay. I did 2 things that we don't like.
Halves.
We have subtraction signs, we have fractions, and we have to distribute.
Ew.
I know, I'm a horrible, horrible, terrible person.
No, you're not.
Shh.
You can fix it.
Oh, thanks, guys.
You can fix it.
I can fix it. Okay.
I can tell you how.
Please tell me how I can fix it.
0.5.
All right. I'm actually going to leave my fractions as they are right now.
Oh.
Can we, hold on. I'll show you one in a minute. Can we start by eliminating my subtraction signs, please? Because I really, really don't like those. Yes, sir.
You gotta remove the one in front of the 7.
The retraction.
Oh, no, the one in front of the 2.
Okay, so in front of the 2, this has to become a plus sign.
Yes.
So I'm going to keep this whole expression as a term. I'm going to change this to addition. Okay, so then that makes that a negative 2?
Yup.
Okay. What about this one?
Are you keeping it the same?
Keep it because it's in the cave section.
Ah. But within the K section, can I have a KCA in there?
Yeah.
Yeah, do I need to?
No, because that puts my brain.
I don't like -4.
Your brain's going too fast.
My brain's going too fast?
I can't keep up.
See, I told you you could do that.
Okay.
You ain't say that.
Shh. Ladies and gentlemen, even if we have a KCA within a KCA, we can still do that. Okay? Because for us to be able to use our properties, that -4 has to turn into plus a -4. Alright? You see now? Oh, you don't? Okay. Remember how before, if we had 3 terms and there was subtraction, we would KCA and the A become the K of the next train? Okay. If we had 3 terms and we subtracted each of them, we would KCA, and that middle term was both the additive inverse of the first one and the keep for the second one? You don't remember that? Okay, we did that.
Did we?
We did. But now within the keep expression, we can KCA. Okay? I need to distribute my 2 next. So I'm going to rewrite my 1/2 x plus -4 plus. What's -2 times 1/2?
Hey, that was a mean word.
What's -2 times 1/2?
-1.
-1.
Told you so.
Told you.
Now, what's attached to that?
X.
Okay, do I have to write the 1 in front of it?
Nope.
No, do you want to?
No.
Let's leave it out.
Alright.
Yeah, put that right.
Plus, what's -2 times 7?
4. 5.
8, 7,
-5.
-14.
How did you get that in the 14?
Because 2 times 7 is 14.
I thought you was subtracting.
And
Oh, it's attorney for the
2 times 7 is 14. A negative times a positive is a negative. Okay?
Yep.
I guess.
Now, I want to rewrite my problem so that my like terms are next to each other. Are my variables or my numbers going to go first?
Not variable.
Variables. 1/2 x plus -x plus -4 plus -14. What's 1/2 x plus -x?
X.
1.
No, 2.
Negative
2
1.
halves.
-1/2 x. If we had a positive x and a negative x, they'd cancel each other out as a 0 pair.
Yeah.
Okay? But I don't have a whole x. I only have half of an x. So that means that half of that negative is left over.
How can you create a half of an X?
Because I don't know what x is. Okay?
Just that?
So it would be -1/2 x. No, you don't write half of an x as just one line. Okay? You have to tell me that it's -1/2 of x.
Alright.
-4 plus -14 is -18. So this would be my solution. Yes, ma'am. Thank you very much.